Great. Question 7.3.48. A recent study reported 26% of the residents of a particular community lived in poverty. Suppose a random sample of 400 residents of this community is taken. We wish to determine the probability that 30% or more of our sample will be living in poverty. Complete parts A and B below. All right, so A is asking us, before doing any calculations, determine whether this probability is greater than 50% or less than 50% and why. Part B is asking us to calculate the probability 30% or more of the sample will be living in poverty. Assume the sample is collected in such a way the conditions for using the central limit theorem are met. Then we will round whatever we get to 3 decimal places. All right, so up here, we need to find a few things. We need our p-value, that parameter proportion value that, so the proportion value that is accepted for the parameter or given for the parameter in this case would be, it's 26%, so 0.26, and it's the entire residents of the community that live in poverty. So 26%. Now we're taking a random sample, so that's going to be important for part A. And a random sample that is n is equal to 400. So that's, we collect a random sample, 400 people from that community. So we pick a random sampling out of the overall total population. So this is a sample. So that goes with the statistic of p hat. I am going to do a p dash hat. We are not doing the fancy p hat here right now. So, and we're being asked to determine the probability that the p hat value is 30% or more, so that it is greater than or equal to 0.30. Okay, but we're actually being asked to find the probability of that occurring. Well, what that correlates to is going to be if we had our population, because we're told it's a random sample and we're going to assume that it's been sampled in such a way to allow it to be normally distributed, then our p-value is similar to mu here with our z. Our p-value is going to be the 0.26. 0.30 is going to be over here to the right. It's the purple and the shaded purple region on that chart. So what we know right away is that if 0.26 is like in the middle, if that's like our accepted value, then half our value should be above and half our value should be below, right, for the population parameter, if we're assuming normalcy with the normal curve. So what that means is this purple region can't be more than 50%. It's got to be less because it's higher than 0.26, right? So we know that the probability is going to be less than 50%. And we know it because 0.30 is greater than 0.26, which was our population parameter, right? Or the population proportion, the proportion for the parameter. I don't remember the exact wording that they have in that question, but the population parameter. And we are able to assume that it has a normal distribution. And that comes from that part where they talk about the random sampling. And then also there's been a lot of that a little bit in this section, but we're going to be looking at central limit theorem here, problem or two. And in part B, they even tell you to assume the sample is collected in such a way. So that's going to be part A. Moving on to part B, to actually calculate that probability. So we're still using the same values. I may just go ahead and copy them down here for you. And assuming that that is collected in such a way that conditions for central limit theorem are met. So we have some things here. In order to do this calculation, we're going to need to go ahead and find a few things. We're going to be doing this on our TI calculator, right? So let's come over here and let's see, what do I need in order to complete this? Well, I have some values given. I have my population proportion that p is equal to 0.26. I have the random sample, n is 400, and then this is the value we're looking for. The drawing above will also help us. I'm going to clean this up a little so you can still see all that on screen. Looking at, so the function that we're going to be using is our normal CDF on the TI calculator. So what do I need to complete my normal CDF? Because that'll help you think about what it is you got to find. So that's one way if you get a little confused ever. So I need a couple things. I need a lower value. I need an upper value because we're trying to determine the area between values, right? I need a mu. In this case, mu would be our p value. And I also need a sigma. So we're going to be using the standard error for that, okay? So our lower, looking at our function above, the lower is where we start for the area that we're trying to calculate the probability of. And for us, it's going to be the purple. So 0.30 is where we start. So that's our lower bound, 0.30. Our upper value would be positive infinity. Well, we don't have that on the calculator, right? So to do that on the calculator, we are going to put our 1E99. Now, when I say that, we are not doing an E letter. We're not doing like the letter E on here. And what we're doing is we're doing what they have this double E in blue. So let me come down. I'll just go ahead and type this part in. I don't know if it'll save it, but just so you see, this will go here. This will be 1, and I'm going to do my second. The double E's is actually just like E. It's for the scientific notation, 99. And this is just you being familiar with your calculator, okay? So you're going to use the EE above the comma, and you're using the second because it's in blue, all right? I guess it would be second plus the comma because it's gonna, that selects that EE above the comma in blue. It's a comma, all right. But we've also gone through it here. Our mu is going to be our p-value, which is 0.26. So the only thing we're truly missing is that sigma or our standard error. Well, we have a nice little formula here. I'm going to try and make this larger. Let's see if I can do that. I'm not sure if I can. Let's do this instead. Maybe let's see if we can zoom in a little on our note. So I put this calculation in here and I wanted to talk a little bit about it. Oh, that makes me so sad. All right, so I played with that a little and I made that a little bit bigger. So what we're gonna do is we're gonna have our standard error or the SC, it's equal to, oh, word, it's not happy with what I did. SE equals P times 1 minus P over N. And I wanted to do it this way because I wanted to talk to y'all. I know sometimes with the calculator, you know, it's really tempting to just type things in as they are. I would recommend simplifying this down before you type it in. So I would think about your p-value is 0.26. Well, what's 1 minus that? And that actually helps drive home some of the important concepts I think you need to know. 1 minus 0.26 is 0.74. I would probably do it as 0.26 times 0.74 and then just divide that by your N or 400, okay? I think that might help with some of the mistakes that maybe people are experiencing because you're not having as many parentheses, it's not as many calculations. So if you know your p-value is 0.26, then we know 100% minus 26%. These aren't super hard calculations. That should be 0.74. And doing that step might help if you were making mistakes getting these and like maybe in class and things. I think that may help, but let's try this now. If I do my square root, I'm going to do 0.26. I am going to multiply that by 0.74. And then I am dividing the entire thing by my N, which was 400. So that is going to give me a standard error, which is equal to 0.0219. And we played with this a little in class, seeing if we needed to round too much. And it looked like doing it by 3 was fine. So let's go back to our distribution function because we have all the things we need now, right? Move this over a little bit for you. So my standard error is 0.0219. So these are all the things that we need right now in order to, go ahead and fill in. So on your TI calculator, so on the TI 83, or 84, whichever one you're using. On the 84, the things that you need, you want to go to, it's going to be second plus the vars, and that's going to select your distribution menu, right? That's what's in blue above it. So the second function always selects the blue. So you see distribution up here. We're going to go down to number 2. That's our normal CDF. So under that menu, number 2 is our normal CDF. So we're going to go ahead and push enter, and we want to fill in. So 0.30. I'll move over a little bit. Actually, I'm going to maybe just go ahead and take this off because we're not using this right now. Oh, yeah, that's better. So we can have a little more room. How's that? Apologize for the jerkiness of that. That should be pretty good. And then we want our upper bound to be infinity, going back to our drawing that we had. I messed with that. I'll play with it a little more later. That would be 1, and we're going to do our second EE99. And I know it only puts that normal E. It's like 1 times 10 to the 99th power. And our next thing that we're going to do coming down, our mu was our p-value of 0.26. Our proportion value, let me not say p-value, of 0.26. And our sigma is 0.0219. And if you don't have that, then what you will do is you'll pick a normal CDF function with an open parenthesis, right? And you'll just insert those values as listed above in that order. And instead of having to like paste it, because what we did is we filled this in using a chart, and then we're just pasting in the command. We're going to hit enter. And so what I got for my value for the probability that someone is 30% or more when I run my, when I do my own sample. So I have 0.033888. Well, it tells me to round 3 decimal places. 1, 2, 3. So this is my 3rd decimal place. I'm going to round that up to 9 because there were 8s behind. There was an 8 behind it. An 8 rounded up would become a 9. And that's going to be the value that I want for part B. So that is going to be my answer. Oops. There is the bold. I saw it now. So we'll go ahead and make that bold. So that's going to be my answer for part B. So rounding that to 3 decimal places. And that makes sense. It shouldn't be a large. We know it needs to be less than 50% from part A. Our standard error was fairly small, 0.029. So that number is pretty far away. I'll try and replace this real quick because I had made some changes trying to make my other drawing show up. So let's see if I can fix this. If I pull it over now. Now I'm going to have to play with it a little. Oops. View as alert. There we go. Okay. So, you know, it's over. So our p-value being 0.026, I mean, that's going to be more than 3 standard deviations away because that'd be 0.28, 0.3. Well, it's over 2. So it should have been about 2 standard deviations away if you think about it in that way. So what do we say for that using our empirical rule, right? Using normality. What about 95%? So take half of that. So that's actually, you know, it's not too bad. So it's about what we would anticipate if we think about it in terms of that. And it's actually a little less because it's 0.02, not exactly 0.0. For the normal, what I was doing, this is actually 0.0219. So it's within 2 standard deviations. So, all right. Let me know if you have any questions.